Hi, everybody. This is Mr. Fowling, and welcome to podcast 1.2. We're going to talk about alloys and mass spec. Hopefully, this is a quick one, but we'll see. We're going to describe what an alloy is. We're going to describe the properties of an alloy. We'll describe interstitial alloys, substitutional alloys, and how isotopes can tell us if something is a mixture or not. So let's hop to it. Alloy is a mixture of two metals. So there are surface alloys, and this is a rare one because usually an alloy is a homogeneous mixture. But a surface area has layers, right? Layers of zinc on iron so it won't rust. This is the one time that it's heterogeneous. Okay? An alloy can change the chemistry reactivity. So what happens is if I have iron, iron rusts. So what happens is I coat it with a layer of zinc, which doesn't rust. Actually, what it does is it reacts with oxygen to make a hard coating that doesn't crumble. So that means the iron inside, which is cheap or strong, will be protected from oxidation. So there are a couple of different types of alloys besides surface alloys. These are the ones that are most important. Okay, this interstitial and substitutional ones are on there. A small atom fits in the spaces between a larger metal. Hey, look at that. I'm a little guy, right? This would increase the density. I don't weigh anything. I weigh something, right? The flexibility decreases. I have air pockets to shift and move. You can't crush me. I'm an atom. And that's it. So that's the flexibility if you're trying to have it bend. Malleability decreases. Same thing happens if you hit it with a hammer. It doesn't shift as much. Ductility, which means your ability to turn into a wire. Malleability and ductility, I always think, are really close to the same thing. Ductility means it's called drawn into a wire, but really you turn it into wire. And the way that happens is based, in my opinion, this is not science fact, this is the way Mr. Fudge sees the world. That it says right there, won't we draw on? Yeah. Is the same thing, the flexibility. Okay. So steel has carbon fitting inside of iron. How cool. Substitutional alloy. A similar size atom replaces or substitutes an atom of roughly the same size. Think next to ish on periodic table. Not up and down, next to. That means their size will be the same. The density would be similar. Their flexibility and conductivity is similar. Brass is an example of this, which is copper and zinc, which if you look on the periodic table, they're pretty close to each other. Hey, right next to each other, they're neighbors. So they can substitute like that. Sometimes it's wanted, sometimes it's not wanted, but brass has some definite different properties than copper and zinc. Elements can have different masses. Okay, so this means that one element of helium could be different than another element. These are called isotopes. So helium's most common ones is helium-4 and helium-5. Carbon-12 compared to carbon-14 are both carbon, but the 14 has extra neutrons, two of them. What the difference is two. Most of the time, this doesn't matter as the less abundant ones are rare, very, very, very rare, very, very, very rare. Okay? Some isotopes are radioactive and turn into other ions or other atoms. So I said ions, I meant atoms. This guy right here, not only is he very rare, he's very radioactive, which means he'll turn into something else. Okay. So, and what it turns into actually is nitrogen, is stable nitrogen. Remember, I expect you to pause these things and write them down and be annoyed as I go quickly, but you can pause them. A mass spec IDs these things, okay? Boron is on the left. So bust out your periodic tables. Dun, dun, dun. I have my periodic table. Boron's average mass is 10.81 on the periodic table. Bum, bum, bum. 10.81. How does this indicate 10.81? Well, look, there's lots of 11. There's some 10. And if I tried really hard to do this abundance, these are relative abundance for these things. So you can kind of eyeball where it comes from. So lots of 11, some 10. So what you would get from this would be average almost 11. Almost 11. And it is, it's 10.81. Now over here, they give you a 3-to-1 ratio and label it this way. So that means it's 66.6%, 35. That's 33.3%. Is that right? No, the whole thing adds up to 1. Shame on me. 3 plus 1 is 4. So that is 75%, 35, and 25%. See how we add up the total? 25%, 37. Okay? So what that means is if I want to find the average mass, I would take my percentage times my mass plus my other percentage. Notice how I use the decimal form? I learned that in my hillbilly middle school. And I add those up. So let's see. Calculators assembled. Dun, dun, dun. 0.75 times 35. Enter. Plus quantity. 0.25 times 37. Quantity. Enter. And I get 35.5. And if I look at the average atomic mass of chlorine, it is 35.45. Oh my goodness, it's a miracle. Review. Alloys are a mixture of metals with a blend of properties. I have some gold properties. I have some copper properties. A blend, not new properties. Draw interstitial alloys. Inter means between. Substitutional means you're going to substitute. Onion rings instead of French fries. Predict which elements will do which type of alloying. So it's by size. That's it. And then the mass spec. Toodles.